Do we be quiet?
No, here we go. I'm recording now. Okay, here we go. Here's what we got. Okay, we have to understand the scenario. Here's the polynomial. This is f of x. And there's going to be a value of k, which is like a missing number, which I'm going to highlight here. And ultimately, this is the question. What is the value of k? What number does this k have to be to make this work? Well, to make what work? Well, read it. Given that this polynomial and the remainder, right? The remainder, when this f of x is divided by what? X minus 2. The remainder, they wrote it all the way over here. The remainder is what? 14. So this is where you got to remember the remainder is 14. Okay, they wrote it here, but they wrote the answer. The remainder all the way over here. So let's set this up. We're going to be able to solve this k, this number. We're going to be able to figure it out by using synthetic division, right? Synthetic division. So you're going to set this up. If this is x minus 2, we know that in the box, what goes in this box here? Not a negative 2, positive 2, right? We're going to use synthetic division. And then here, always check that this is in order. Make sure there's no missing terms. So I got 3 for the x squared and k for the x, but I'm really just going to put like an empty, just like an empty box. This is my value. What value does this k have to be? What number does, and then 12. See, you're setting up, you're doing synthetic division, but it's just kind of in a little tricky way here. And again, here's the important part. They have to tell you the remainder. The remainder is what? 14. See? The remainder is 14. So I got some information here in the front to start, and I got some information actually back here. And I'm just going to tell you now, in order to figure this out, you're going to have to kind of start and work the problem this way from the beginning, and then you're going to get stuck, and then you're actually going to work backwards and work this way since you know the answer for the remainder. Okay, does everybody understand that that's what's happening here? You're going to use synthetic division. You're going to have this k, this number that we don't know. I'm just putting a box for now. And we have the coefficients and we have the remainder. Okay, so let's do it. Here it is. Synthetic division means, well, we understand it. We start with that 3. We drop it down. Okay, that goes under this line. And then what happens to these two? We multiply them. So that's 2 times 3. And doesn't that usually go here? And then normally we would have a number here, and wouldn't we add these, and then we'd put a number here? Mm-hmm. But see, we're stuck. I can't add k plus 6. I'm not going to put that here. So this, we're going to have to figure it out. So now I'm stuck. See, I can't go any more past this way. So you start, work the problem this way, and now I can't go any further. So now you're going to start from back this way, from knowing the remainder, and work your way back. And we're going to meet here in this middle where this k is. So does everybody agree that these have to add to give us this number? So what would this number have to be? 2. See, you understand synthetic division. You know what these numbers have to do. So you'd have to know that this has to be a 2. Now, if that has to be a 2, everybody, what goes here? What number has to go here? A 1. How did you get that? Well, just like you understand that 2 times 3 is 6, and that would go here. If I have a 6 here, then I know that this would have to be a 3, right? Because 2 times 3 is 6. If this is a 2, this would be 2 times 1 to give you the 2. You guys see how I'm working backwards? Because you understand synthetic division. Okay. Now we're right here. Who can tell me the answer for k?
-5.
Okay, how did you do that?
Because -5 plus 6.
You understand that these have to add, right? Remember these have to add? If I were you, you don't want to be guessing here. I would set up a kind of like an algebra 1 problem, right? I would put k plus 6 has to give me what? Isn't that what's happening? Isn't that a simple algebra 1 equation you can set up? What does k have to be so when I add 6 to it, gives me 1? That's algebra 1. But I know this one's simple enough you can do it in your head, right? 6 plus what can give me 1? Well, it has to be a negative number. We know it's going to be what? Negative 5. You guys see how easy that is now? That's what it's asking for you to do. Find that value of k. Are we good? Okay, can we go faster now? Yeah, let's go to number 2. Boom, number 2. Go ahead, set it up. Go ahead, find out what the remainder is. Make sure there's no missing terms. Set this problem up. Okay.
What the heck is factor?
We're not there.
Can you tell me?
No. We're working on this. Okay. Let's set this up. What do we know? We know that this says x minus 5, so everybody agree positive 5 goes in that corner box up there? Yeah. And watch out here. Make sure there's no missing terms and put the right numbers, these coefficients. So 3 for x squared, negative 10 for the x, and k is that last number, right? That's the last number, k, yeah? And what else do we know? On this one, the remainder what? It says that all the way over here, the remainder is 40. So r is 40. Or the remainder, which is this last number. The remainder is down here, right? This last number down here. You guys see that? Okay. Now you're going to work your way this way until you get stuck, and then you're going to work your way backwards, and then you're going to figure it out. Did you guys get it? Anybody get it? What did you get? Joshua?
15.
And positive 15?
Yeah.
And George?
15.
Positive 15 again? Anybody get a different value of k? All right, let's do it. So do we know this already? Yes, you do. You understand synthetic division, but to do these problems, which are a little twist to a missing coefficient, this is how you approach it. Okay, drop the 3. We're going to start this process. Drop the 3. And these multiply 5 times 3, and then I multiply these, and it goes here 15. Is that right? Yeah. And then these add, right? These add, so that's going to be 5. And then 5 times 5 is 25. Is that the value of k? No, 25 goes here. And then here is where you got to understand that what? These have to what? Add, and I already know what the sum has to be. So this is where you set up a simple what? An algebra 1 equation, right? You understand that this value, this unknown, I have to add to 25 and get the answer 40. Well, we're going to get 15, right? Are we good? Is this easy? Okay, moving on. Next one. K equals 15 is correct. Any questions? Fácil. Next. Up. Question.
Do you have to write it as the form that you...
Like an answer like the other ones? No. See, because it just says what is the value of k. You don't have to write the whole, like answer this. And no, you don't have to do all that. Okay? Okay, let's do this one. Okay, I'm going to do this one quick. So x minus 3 is the divisor, so that means a positive 3 goes here. And the numbers are 3 for the x squared, negative 2 for the x, and k is the last one again? Yeah. And the remainder is what?
35.
The remainder is 35. Are we good?
Yep.
The remainder goes down here because that's usually where the remainder is, right? And I think you're going to get this one now, right? Okay. Let's do this. So 3, multiply these, that's 9. Add these, that's 7. Multiply these, that's 21. Is that the answer, 21?
No.
No. This one was almost like the previous one, right? Okay. And then here it's like what? What do you understand? Well, k plus 21 has to give you 35. What does the value of k have to be? I got 14.
Yes, sir.
14. Okay. We got to know how easy this is? Is that okay?
Yep.
All right. Go ahead and do the next one. Flip the page over. There's more problems on the back. Oops, let me get a better paper here. Okay, here we go. All right. Go ahead and do this one. I'll give you a minute. Okay, so this problem looks harmless, looks just like the other ones, but guess what? Something tricky here, right? You guys caught it? There's a missing term. If you didn't catch the missing term and you didn't put the 0 for that missing term, it's not going to come out right. So, x minus 2 is... You got negative 21? So I got 3 different remainders. Negative 19, negative 11, negative 21. Okay, let me do it and then I'll work it out. Did you guys use a positive 2 there? Yeah. And did you make sure that you checked for missing terms? So you should have a 2 for the x cubed, a 0 for the x squared. Did you put a 0 for the x squared? If you didn't, well then you got it wrong. A negative 10 for the x and k for the number, right? Okay, if you didn't set it up like this, and there you go, you didn't set it up right and you didn't put that 0, you got it wrong. And we know here that it says the remainder is what? I have to know a remainder. The remainder is what? Negative 23. Did you guys set it up correctly? Okay, if you set it up correctly, then I hope you didn't get anything wrong, but it's possible you still made a mistake. Here it goes, ready? Drop the 2, then these multiply 2 times 2, that's 4. Then these add, so that's 4. Then these multiply, and that's 8. And then these add, and that's negative 2. And then this is going to multiply, so that's negative 4. And what do you understand about this? Well, I understand that these have to add to give me this answer. So you're going to set up an equation here. K take away 4 equals negative 23. K is equal to negative 23 plus 4. Yeah, you should have got negative 19. Negative 19 is the correct value of K. Are we good? Watch out for missing terms. Okay, last. Oh, no. These are the good ones. Here's the ones that are different. Okay. What's different about this?
It's like the factor or remainders.
I'm going to show this again over here. Okay, these last two are different. Something's not the same as these previous ones. What is different? Can somebody tell me? It doesn't tell you a remainder. Does everybody understand that? So what does this mean? What's going on here? Given that here's the polynomial with the k right there, given that f of x and x plus 1 is a factor. Here's the key thing. You got to understand that. If you don't understand what this means, then you don't know what the remainder is. Then what is the value of k? Okay.
Can do synthetic division.
Yeah, you can do synthetic division. You just don't understand this part. Ready? Here it goes. Okay, let me show you this. Okay. Let's talk about factors. Ready? Watch here. Is. I'm going to put a number here. A factor of blank. Ready? I'm going to put some numbers here. Is 7 a factor of 14, everybody? Yes or no? Yes. Well, what does a factor mean, guys? What is that? What is that word, a factor? Is 7 a factor of 14? You said yes, and I agree. The answer is yes. But why? Why is it true that 7 is a factor of 14? Well, let's see. Let's keep going. Let me ask you another one. Is 7 a factor of 35? And you're still going to say yes? Okay, yes. Now in math, how do you prove that? I know you're saying, well, yeah, I know because 7 times 2 is 14. Okay, and you're like, yes, I know because 7 times 5 is 35. Okay, I know that you know that. But now my question is 7 a factor of 80?
No.
And you're going to say no? Okay, prove it.
We can't multiply to 80 unless you use a decimal.
Okay, I know you're thinking of multiplication. I know you're thinking about that. That's true. But honestly, the way you prove it, and obviously this whole unit that we've been working on is division. You got to prove it by division. How do you prove that something is a factor by division? Well, you understand the fact that 7 goes into 14 twice, and the remainder is what, everybody? 0. When something is a factor, when a number is a factor, it divides, and your remainder has to be 0, right? That's what a factor is. Yes, it's true that it's multiplication, but to prove it or to disprove it, you divide, and the remainder is 0. Does 7 go into 35? Yes. And it goes into 7 times 5 is 35. Your remainder would be 0. How can you prove that 7 is not a factor of 80? Well, go ahead and try to divide it. When you do 7 into 80, 7 times, I think 11, right? 7 times 11 is 77. And see, we'd get a what? We'd get a remainder. If a remainder exists, is it a factor? No, it's not. See, that's how you prove it. But the understanding is this. The understanding is, if it's a factor, the remainder has to be what? 0. If something is a factor of something else, when you divide, the remainder is 0. Is 7 a factor of 112? Is 7 a factor of 112? I know you don't know 7 times something, so what would you do? You divide, right? Is 7 a factor of 112? If my remainder is 0, it's a factor. You guys agree? And what happens when I divide 7 into... Is 7 a factor of 112? Yes, because what? When you divide, the remainder is 0. 0 being the remainder means that it's a factor. Okay, so let's go back to this. This is not going to tell you that the remainder is 0, but it's telling you that x plus 1 what? Is a factor. Indirectly, that tells you that what? The remainder is what, guys? The remainder is 0. See? It's not going to tell you the remainder is 0. It's going to say it this way. X plus 1 is a factor. Well, that means that your remainder has to be 0. Does that make sense?
Yeah.
Okay. So we're going to do this exactly like the other ones. X plus 1 is the divisor, but negative 1 goes in this box. And, again, watch out for missing terms. 2 for the x cubed, 0 for the x squared, 7 for the x, and then k. Yeah? And, yeah, I do need to know what I need a number here. What's the remainder, right? 0, because it is a factor. See, it's not going to give you a number for the remainder like the other problems. If it's telling you that it is a factor, you have to understand that the remainder is 0. Okay. Other than that, we should be really good with this. 2, negative 2? Negative 2? Positive 2? 9? Negative 9. What must the value of k be?
9.
Positive 9, right? Because these add, and the opposite of negative 9 is positive 9. Money, easy stuff. Easy when you understand something, yeah? Okay, go ahead and do the last one quickly by yourself. Watch out for missing terms again. And again, this one says it is a factor. Well, that indirectly tells you that the remainder is what? 0. All right, go ahead and work that one out. Okay, I'm going to do it quick. 2, 3, 0, negative 5k. And 0 is a remainder because it's a factor. All right, it's not a race. Here we go. 3, 6, 6, 12, 7, 14. I got negative 14. Was that right?
Yeah.
Or did I mess up? Is that good? All right, there you go. So not too far from what we already know, yes? I told you, you're going to apply previous knowledge to new situations. Great. There you go.